Hello teachers and students. I'm Lucas,
I'm Rodrigo.
And I'm Adriano.
and today we're going to be talking about microwaves and cell phones.
Microwaves can pop your popcorn. They can catch you speeding. They carry thousands of phone channels to speed your calls. But can microwaves help us learn about our world and our universe?
Microwaves are the most fundamental part of cell phone communication as they function as a medium to transmit and receive signals that come from cell phones, signal towers, and hubs.
Microwaves range from 30 centimeters to 1 millimeter, so they fall between radio waves and infrared. To understand how cell phones use microwaves, we must first understand microwaves. Unlike radio waves, microwaves are waves made up of short wavelengths and high frequencies. Microwaves can be found in microwave ovens and radars. The time it takes for the reflected wave to return is used to calculate the object distance, and the object speed can be found by using a car as an example. When a policeman tries to find out the speed of a car using a radar gun, because when the waves interact with the car, they change frequency, and therefore the gun notices the change.
There are also two types of cell phones. There are satellite cell phones which run directly off a satellite in outer space, and the most common are normal cellular cell phones we all use, which work through cell phone towers.
Cell phones work only if they are in the cellular system. The cellular system divides regions into small cells, also known as geographical areas. Every cell has one or more towers that broadcast signals to a central hub. When you make a phone call to your friend on your phone converts the voice into an electric signal that is transmitted to the form of radio waves to your phone. The hub that transmits the signal to a receiver, depending on the distance between the two callers, the hub may transfer the signal to another tower or another hub. The tower or hub will transmit the signal to the person receiving the call. Once the cell phone picks up the signal, the phone will ring. This sounds like a quite complicated process, but it happens so quick it's almost immediately. Cell phones are used to send text messages, browse the internet, take photos, make calls, and more. Cell phones can be used for many different things.
Bad cell phone reception is a very common problem. It can happen because of mainly two things. One of them being you're out of range or too far away from the tower, and the second reason being you're in a place where something is blocking the signal, mainly for insulation purposes. For example, the PAC. Have you noticed that while you're sitting in the pack, you don't have or have very bad reception? This is because there's a destructive interference that is preventing the signal from reaching your phone. Also, when you visit remote areas, the signal will be worse because the government will most likely to invest money into populated areas to put towers rather than in unpopulated areas which are further away to the city. As you can see, this is the electromagnetic spectrum, and as we can see, microwaves fall between infrared radiation and radio waves.
Different wavelengths of microwaves can help us identify several things, such as C-band microwaves penetrate through clouds, now snow, rain, dust, and smoke, which help us identify things on the Earth's surface. L-band microwaves are used for forest mapping and identifying things such as deforestation. L-band microwaves are also used on GPS ground positioning systems, like the one in your car.
As we can see, this diagram demonstrates many colors. This is because there are different types of microwave rays that demonstrate different things such as deforestation and rain.
One important phenomenon is unique to microwaves. In 1965, using long L-band microwaves, Arno Penzias and Robert Wilson made an incredible accidental discovery. They detected what they thought was noise from their instrument, but was actually a constant background signal coming from everywhere in space. This radiation is called cosmic microwave background, and if our eyes could see microwaves, the entire sky would glow with a nearly uniform brightness in every direction.